Hello viewers, welcome to Simplified Maths class. And today we are going into statistics part 2, which is the measures of central tendency, mean, mode and median for a grouped frequency distribution table. If you look at the table here, you see that the table has been grouped. Alright, there is no precision. You see that in this particular test, two students scored between 41 to 50. So we don't know exactly what the two students scored. Now 12 students scored 51 to 60, and then 20 students scored 61 to 70, 10 students scored 71 to 80, 5 students scored 81 to 90, and then 1 student scored between 91 to 100. So there is loss in precision because you won't know what exactly each student in that class scored. So here when we are asked to find the mean, mode and the median, we go into the following. So please watch. We need our table of values first and foremost. Solution. So in our table of values, we are going to have the class limits. You need the class limits. After the class limits, we need the class mark. Our class mark is our x. After the class mark, we need the frequency. After the frequency, we need cumulative frequency. Alright, and then I think we also need the class boundaries. So we need also the class boundaries. So we need class limits. We need our class boundaries. Class boundaries, class bar, frequency, cumulative frequency, and finally we need our frequency times x. That's all we need. Alright, so class limits we have 41 to 50. The next is 51 to 60. The next is 61 to 70. The next is 71 to 80. The next is 81 to 90. And then 91 to 100. So that's all we need. So after the class limit, we need the boundaries. The boundaries has to do with between this class and this class, there is a boundary. And that boundary is to move from 50 to 51, you have 50 and a half here, which is 50.5. That's the boundary. And then to move from this class to this class, there is a boundary here. So and that boundary is between 60 and 61, which is the line here, 60.5. Alright, so we need the first boundary here, which is 40.5. There is a boundary here, 50.5. There's a boundary here, 60.5. There's a boundary here, 70.5. There's a boundary here, 80.5, which is the halfway between 80 and 81, 80.5. The boundary here, which is 90.5, and so on. So our beginning boundary here will be 40.5 to 50.5. Alright, that's the lower boundary and the upper boundary. Alright, so before you get to 51, you have the boundary which is 50.5 to 60.5. Before you get to 61, we have 60.5 to after 70, 70.5. So we bring down 70.5 to the next boundary which is 80.5. We bring down 80.5 to the next boundary which is 90.5. Then we'll bring down 90.5 to the next boundary which is 100.5. So that's what we call the class boundaries. They are very important when we are solving the mean, mode and the median. Okay, so we go to the class mark. The class mark is the representative mark for the class, meaning that those that scored between 41 to 50, what single mark will represent that class? That is the class mark, the representative mark for each class. And for you to get that representative mark for each class, all you need to do is to add 41 to 50 and divide by 2. So 41 plus 50, 41 plus 50. Alright, when you divide by 2, you have 45.5. So the class mark is 45.5. That's the class mark. So the next class mark is to add 51 to 60 and divide by 2. You're going to have, make sure when you're adding 51 to 60, 51 plus 60 equals to, get your value before you divide by 2. You're going to have 55.5. So the next one, 61 added to 70 equals to, before you divide by 2. So you have 65.5. So the next will be 75.5, the next will be 85.5, and finally 95.5. So that is the class mark, the representative mark for the class. So we need the frequency. Our frequency is given 2, 12, 20, 2, 12, 20, 10, 5, 1, 10, 5, and 1. Alright, so we need the cumulative frequency. 2, alright, 2 plus 12, you have 14. 14 plus 20, you have 34. 34 plus 10, you have 44. 44 plus 5, 49. 49 plus 1, 50. Therefore means that the sum of the frequency is 50. If you add the number of students in that class, you should have 50. And then finally, we need the last thing, which is frequency times x. So we need our frequency times x. Alright, so which is the multiplication of x here, the class mark, times frequency. Alright, so 45.5 times 2 will give us 91, I believe. Alright, 91. So the next one, 55.5 times 12. So we have 66. So the next one, we have 65.5. We'll multiply by 20. By 20, 1310. So the next one, we have 75.5 times 10, which is 755. So the next one, we have 85.5. 85.5 multiplied by 5. So we have 427.5, 427.5. And then finally, we have 95.5 multiplied by 1, which is still 95.5. So we are going to add on that 95.5 plus 427.5 plus 755 plus 1310 plus 666 plus 91. So we have 3345. 3345. So we need our mean mode median. Very easy. Number one, our mean. Of course, we say the mean is summation fx all over summation f, alright? Or you can make the summation sign this way. It covers for fx and f. Alright, so summation fx, the sum of fx, 3345, 3345, all over summation f, which is 50. So 3345 divided by 50 will give us our mean, 66.9. Therefore, the mean is 66.9. That's our mean. Please take note of that. After the mean, we need the mode. Alright, so our mode will be equals to, now for a group frequency distribution, we have a special formula for the mode, and the mode is given as lower boundary of the modal class plus delta 1 all over delta 1 plus delta 2 multiplied by c. Alright, so the mode is the lower boundary of the modal class plus delta 1 all over delta 1 plus delta 2 multiplied by the class size. So we need to bring out the values of all these Lm. First and foremost, we have to identify the modal class, which is the class with the highest frequency. And if you look at this, this is the highest frequency. So the class that has the highest frequency is this class. Is this class, the whole of this class. So that is the modal class, the class with the highest frequency. So we need Lm. Lm is the lower boundary of the modal class. These are the boundaries. These first boundaries are the lower boundaries, and these other ones are the upper boundaries. So the lower boundary of this modal class is 60.5. So we record it 60.5. That's the lower boundary of the modal class. So we need, the next thing is delta 1. Delta 1 is the difference between the modal frequency and the frequency before it. The difference between the modal frequency and the frequency before it. The frequency before it, meaning 20 minus 12. That's what it means. So you have 20 minus 12, and that gives us 8. And our delta 2 is the difference between the modal frequency and the frequency after it. Delta 1 is the difference between the modal frequency and the frequency before it. Delta 2 is the difference between the modal frequency and the frequency after it. So that will be 20 minus 10. So we have 20 minus 10, which is equals to 10. And finally, C. C is the class size, the class width, or the class magnitude, meaning how large is that class. Now, every class has a class size of 10. From 41 to 50, it is 10 digits. From 51 to 60 is 10 digits, and so on. How do I know that? So if you count 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So there are 10 marks that makes up each class. So every class has a class size of 10. So we record 10. Alright, so with that we can now find the mode. With this we can now find the mode, and so I'm going to clean this now to represent these values into the formula. Alright, so please watch me as we take that. This is a very serious matter. Okay, so let me clean this so that I'll have space to work. Alright, so I need this. Let me clean this. Alright, so we can now say our mode now is equals to, so the lower boundary of the modal class is 60.5. I record 60.5 plus, I open my bracket. Delta 1 is 8. So I record 8 all over delta 1 again, which is still 8, plus delta 2, which gave us 10. And then we multiply by the class size of 10. So we are going to have 60.5 plus. Alright, so we have 8 over 8 plus 10, which is 18. Then multiply by 10. So we are going to have 60.5 plus 8 times 10 is 80 divided by what? 18. Alright, so we are going to have 60.5 plus 80 divided by 18. 80 all over 18 will give us 4.444. So we have 4.44 into 2 decimal places. Therefore, our mode will be equal to 60.5. Alright, 60.5 plus 4.44. You have, okay, 60.5 plus 4.44. So we have 64.94. So it therefore means that our mode is 64.94. And please take note, the value you have for the mode must fit into the class. 61 to 70. It mustn't be outside that class. The value we have, 64.94, is definitely between 61 and 70. So if you have a value that is not in that class, it means you're wrong. It must fit into that class. So that is the mode. So the next thing we need is the median. Let me introduce the formula for the median for a group frequency distribution table. So our median for a group frequency distribution table will be equals to the lower boundary of the median class plus the rank minus cumulative frequency before the median class all over the frequency of the median class multiplied by the class size. So the median for a group frequency distribution is given as the lower boundary of the median class plus the rank minus the cumulative frequency of the median class, cumulative frequency before the median class, all over the frequency of the median class multiplied by the class size. So let's interpret them all in their numerical values, L of M. Okay, so we first need to find the rank. The rank will help us first. Now notice that the rank for a raw data and a frequency distribution table that is not group is n plus 1 over 2. But when we are dealing with a group frequency distribution, the rank is always n all over 2. Whereas the rank is n plus 1 over 2. Why is it n over 2? Because there is loss in precision. The data is grouped, and so there is no accuracy. So there is loss in accuracy. So we have n all over 2. Our n is the sum of the frequency, which is 50. So 50 divided by 2 will give us the median rank, which is 25th position. So we must first identify the median class before we can find other values we want. So from the 25th position, we are going straight to the cumulative frequency to see where the 25th will fall. So if you watch here, 25th cannot go in here. 25th cannot go in here. So 25th will fall into here. So 25th are falling into here. Therefore means that the median class is also this class that we have ticked. Please take note, sometimes the modal class and the median class will clash to be in the same class. But sometimes you can have the modal class in one class and the median class in another, and the median class in another. So please take note. Alright, so here we have the modal class and the median class in the same point. So we can identify other parameters. The first one is L of M. L of M, as we said, is the lower boundary of that median class, which is still 60.5. 60.5. And then we've gotten n over 2, which is the rank, 25. Then cumulative frequency before the median class. Before this class, What was the cumulative frequency? 14. Alright, this cumulative frequency. Before this class that we have ticked, what is the cumulative frequency? That's 14. So cumulative frequency before the median class, CFB, that's 14. Alright, so we need the frequency of the median class. That very median class, what is the frequency? The median class, the frequency is 20. So the frequency of the median class is 20. And of course, the class size is still 10 because every class has a magnitude of 10. So we are going to input this into the value of, into the formula for the median to find the value of the median. So let's go. Median. So we have therefore our median will be equals to L of m plus this is, so what is our L of m? 60.5. So we record is 60.5 plus, we open our bracket, n over 2, the rank is 25. So we record 25 minus CFB, which is cumulative frequency before the median class, which gave us 14, all over frequency of the median class, which is 20, which gave us 20, then multiply by the class size, C, which is still 10. So we are going to have 60.5 plus 25 minus 14. 25, 11, 25 minus 14, that's 11. All right. I want to be sure. 11. All right, so we have 11 all over 20, and then we times by 10. So we are going to have 60.5 plus 11 times 10 is 110 divided by 20. All right, so we are going to have 60.5 plus 110 divided by 20. That gives us 0.5. No, it can't be. All right, 110 divided by 20. You have to be very careful. 5.5. All right, so that'll be 5.5. 5.5 added to 60.5 will give us 66 by the grace of God. All right, so 5.5 plus 60.5. I like being sure of my values so that I don't make mistake. So that's 66. It therefore means that our median is equal to 66. And take note, the median will also fall in between that class of 61 to 70. So if you have a value that is before 61 to 70 or after 61 to 70, you judge yourself and know that you are wrong. So the median will also fall in that class. So far today, we've been able to handle the mean, the mode, and the median for a grouped frequency distribution, which is always the number one math you meet in every statistics, especially in year 2 statistics, all right, and year one mathematics that has to do with statistics, and then third year quantitative techniques. You will always meet it in the higher institutions. So thank you very much for watching our classes today. I would love you to subscribe to this video and click on like as well. Then if you have any question, please make sure you ask the question in the comment section of this class, and your questions will be answered. God bless you, and see you in the next part of statistics part 3, which is the measures of dispersion. God bless you.